here. So
I have a
properties.
question for my math lab.
Hmm.
I have a question for my math lab.
Okay.
It doesn't ever say like it doesn't ever say any dates or anything, or it
That's because
doesn't list what's due.
we have a hard due date at the end of the semester. So I think it's May 7th for you guys. That's in
Yeah.
SIS. So I gave you guys that hard due date at the end. So what you're supposed to be doing is, we're in 7.1. So really you
Mhm.
guys should be ready to jump into chapter 7 as far as my math lab is concerned,
Right.
or close to it.
Right.
Because you don't want to be too far away from 7, because that means we're continually adding new stuff, and you
Yeah.
still got old stuff back there. But what I
Mhm.
did was I made that the hard due date, just so, if life were to happen, you don't have to ask me for any type of extension or anything like that. That last due date is when everything has to be done.
I
And so
like
that's,
that better. Like I
say
don't know
again.
why,
Gotcha.
but I like that.
Yeah,
As
yeah,
long as
yeah,
you stay
Yeah.
on
Well,
top of it, though, you know what I'm saying? As long as you stay on top of it, but yeah.
yeah.
I feel that.
So was
let
somebody
me
else saying
catch
something?
up.
Oh, you said you need to catch up.
Yeah.
Yeah, and that's what I said in the beginning of class. If not saying you are a professional procrastinator, I was just saying in general, if you are a professional procrastinator, then this way may not be the best, because some people need these due dates to keep them on track. But
Yeah.
like I said, the way you can gauge yourself is say, okay, what section are we in as far as the lecture is concerned? That's
Right.
where I need to be, or need to be heading towards or getting close to. And
Gotcha.
so, yeah, yeah. So that's your marker right now. And then, like I said, when we get closer to closing out the semester, you really know that, hey, I need to get on top of this, because this date, there's nothing I can do with that date. You know. All right. So 7.1, properties of normal distribution. When we talked about the normal distribution um, before, earlier part of the semester, remember we said we are going to get to it in the application of it. That's a bell-shaped curve. It's symmetric about the mean. Well, we'll talk about the characteristics in a second. But yeah, that bell-shaped curve is the representation of our normal distribution. So hold on one second. All right, probability density function, PDF for short. An equation is used to compute probabilities of continuous random variables. So now it must satisfy the following two properties. The total area under the graph must equal to 1. We're going to talk about what that means more as we progress forward. And the height of the graph must be greater than or equal to 0 for all possible values. We talked about that before as well. Your probability has to be in between 0 and 1, inclusive. I'll let you guys copy that before we go to the next piece. All right. All right. A continuous random variable is normally distributed or has normal probability distribution if its relative frequency histogram has the shape of the normal curve. Scroll up. If I scroll up too fast, you still copying, of course, let me know. So this is our normal curve. We talked about that already, the shape. In the middle is our mean. And when you add a standard deviation, subtract the standard deviation, that's where we have our inflection points. And inflection points on a curve is just where the curvature of the graph changes. So in other words, the concavity changes. So it goes from being, and that's what this red box is talking about right here, being concave up to concave down. So having a U shape is concave up, and then having it upside down is considered concave down. So inflection points are just where the concavity changes. All right. All right, properties of the normal density curve. I think we have like 8 of them. Number 1, normal curve is symmetric about its mean. Number 2, mean, median, and mode are equal, and it has a single peak and its highest point at x equal to the mean. In other words, we saw that. So we're talking about right here in the middle, the highest point. Already mentioned property number 3. It has inflection points at when you subtract standard deviation from the mean and then add a standard deviation to the mean. Oh,
You good? You drop your phone?
drop my pen.
It sounded like the phone. I was gonna ask, have they said anything about going back to normal schedule, or are we doing this again next semester?
Well, I know
like just so I can like mention.
Right. Well, I know the summer is going to be just like this. Now in the fall, they're still trying to work that out. They're already asking us, who feels comfortable going back, under what conditions and stuff like that. Well, I'm sorry, they're asking us. They're not asking y'all.
Okay.
Because if we don't come, then ain't no purpose of y'all going back.
I
I know that when I go back, I'm still going to incorporate a lot of what I'm doing anyway.
Right.
As far as recording lectures and stuff like that. I may even have a way that I would do a hybrid, wherein some people, if you want to come in, you come in. If not, you can zoom it in. I might do something. I'm gonna try to do something like that. Figure out a way.
Oh, that'd be cool. Like record the lecture while it's in process or something that way. Oh, that's cool.
Yep. And then if you're not feeling well that day, but you feel well enough to sit through a lecture, you could do it from home.
Yeah.
Live. I just got to figure out a way to project this onto the screen. But,
right.
I think it's a way.
Yeah, that'd be cool.
Yep. So did number 3. Number 4, area under the curve is equal to 1. So we said under the curve, we're talking about this right here in the red. All right, under the curve, that's equal to 1. So what I was saying right here is that if you know 0.7 is to the left of a number, then that means 0.3 would be to the right, because both of those add up to 1, right? So same thing as if 0.3 or 0.6, let's say if 0.6 is to the right of a value, then you know 0.4 would be to the left of the value, because it all supposed to add up to give you 1. And so the application of that, like I said, we'll talk about as we progress further. But everything under the curve is equal to 1. It's equal to 1. So it's going to represent something for us. But like I said, we'll get there. Number 5, the area under the curve to the right of the mean is 50 or 0.5, 50% is half. And the same thing goes to the left, because remember, it's symmetric about the mean. What goes on the right side of your mean goes on the left side of your mean as well. Your mean is right there in the middle, and everything reflects about your mean. Number 6, as x increases, the graph approaches but never reaches the horizontal axis, which is 0. Same goes for x decreasing. So if you notice the way I drew this graph over here, notice I didn't allow it to touch. And that's because of that principle. As it goes to the right or as it goes to the left, if you follow the graph as it goes to the right or follow it as it goes to the left, it is never supposed to touch the horizontal axis. It's supposed to approach 0, but never actually get there. right, questions, any questions? Seven, the empirical rule. Let's see, anybody holding on to five? All right. So the empirical rule, we've already dealt with this before, but I was just throwing it back up there, throw everything up there about it just to make sure we're okay. That five is nine. That's good. All right, so the empirical rule, approximately 68% of the area under the curve is within one standard deviation of the mean. Approximately 95% of the area under the curve is within two standard deviations of the mean. And then approximately 99.7% of the area under the curve is within three standard deviations of the mean. All right, and that's the, hold on. Anybody holding on to the first one? Are we good? Are we good?
Very good.
All right. All right, so that's the diagram. And we talked about, it's the same diagram from chapter 3, I believe. Chapter 3, we first introduced this concept. So that whole thing is the same. Where, you know, your percentages inside, all of the percentages hold true. They add up to give you the 68, 95, and 99.7. I'll erase that one as well. And then the numbers down bottom will change according to what your information, you know, the information given. So whatever your mean and your standard deviation is, that's how those numbers will change. But once again, these percentages never change. So I think I have an example where we're going to reemphasize the process, but just make sure you guys got it before we move on.
I took a picture of it.
No problem. All right, everybody good before we go to the next thing? All right, so in this next example, we're going to reemphasize that process. The birth weights of full-term babies are normally distributed with mean 3,400 grams and standard deviation 505 grams. So let me erase this. And I'll put it back. I want to make sure we're okay with how we get in there. So once again, those percentages, no matter what problem you're dealing with, if you're leaning on the empirical rule, those percentages will always be the same. You got 30, remember your mean is in the middle. That's 3,400 for us. Then we got 34%, 13.5%, 2.35%, 0.15% on both sides of the mean. All right. So now the key here is to figure out the little tick marks that separate the 34, 13, 2.35, and the 0.15. So to go about the right side, that's what I have here in the purple. You're going to take your mean and add a standard deviation 3 times. So 3,400 plus 505 gave you 3,905. Add 505 again, that gives you 4,410. Add 505 a third time, that gives you 4,915. So those are your 3 numbers to the right of your mean. All right. Any problems with that?
I know, and then my mean is something that shows up more than once, right?
Say it again.
My mean is something that's going to show up more than once in the middle.
No, that's so your mean is your average.
Okay.
And it's just going to be slap dab in the middle.
Okay.
And then so now, if you talk, oh, I had my erase on. So if you're talking about right here, it just shows up more than once in your calculation.
Okay.
But if you really just want to, you know, add 505 here, add 505 here, and then add 505 here, then that's all you're doing.
Okay.
Yeah, it just showed up more than once when I write my notes.
Okay. Okay.
But it's only going to show up one time in your diagram, which is right here. And then those three purple numbers that we just had will be to the right of your mean. Then to the left of your mean, you're going to subtract 505 three times. So 3,400 minus 505, 2895. Minus 505 again, that'll give you 2390. Then minus 505 one more time to give you 1885. All right, everybody good? So I'm gonna put these numbers back so we can see how it looks. So you see we got 3,400 in the middle, then we have our numbers to the right, and now our numbers to the left. And all is saying that, you know, in between 2895 and 3,400, that would be 34% of our data, or it's a 34% chance that the number, what are we talking about, babies? 34% chance that a baby born full term will weigh between those two values. Or it's a 13.5% chance that they will weigh between these two values. So that's how we can use this information to come up with our conclusions. And our conclusions are based on, you know, the data that has been given, you know, to us, the observations that we've already received. And remember that both of these numbers represent an amount of data that we've already collected. And that's how we got those numbers. And so that's why we're able to lean on it. All right. Questions on that process? Very good. Another type of exercise in this section. Let me, I'll just erase it right now just so that, see what the original question is. Shade the region that represents the proportion of full-term babies who weigh more than 4,410 or 4,410 grams. All right. So when you look at this diagram, and what's going to happen in my math lab is they're going to give you like a couple diagrams to choose from, which one is accurate. And so you're going to compare that 4,410 to the mean. If we go back, remember our mean was 3,400. And our mean is in the middle. So that 3,400 will be right here in the middle. So 4,410 is going to be greater than the mean. So it should be slightly to the right of, and that's what I have in this depiction right here, slightly to the right of the center. So that's why you had to ask yourself, is it less than or greater than the mean? Because if it's greater than the mean, it'll be to the right of the center. But if it's less than the mean, it will be to the left of the center, right? If you talk about numbers, just the number line, if you have the number 1, anything greater than 1 would be to the right of it. Anything less than 1 would be to the left of it. So that same thought process when you talk about what shading is correct. And then also more than is going to let you know you should be shading to the right. You know, if it's greater than, once again, it'll be to the right. If it's less than, it will be to the left. And so that's why we shade to the right. And here, I just did the scenario. If they were asking to the left, less than, then you would be shading to the left of that 4410. So once again, they'll give you, a couple diagrams, then you'll choose the right one. And so if they're asking you about more than, you shade to the right of the data value they gave you. Less than means your shade to the left of the data value that they give you. Questions. All right. Oh, so that's it for 7-1.
What? Yeah, you weren't lying.
So
That
yeah,
was quick.
Yep. Somebody said that was quick. Yeah. So that's what I was saying. We could really do 7-1 and 7-2 today. But like I said, I'm trying to, you heard one of your classmates confess. She had a moment of confession saying that she needed to get caught up. So try to afford those opportunities to you guys. And like I said, not hit you too much with a whole bunch of information. Because like I said, we would have done 7-1, 7-2 today. Here's another one. Chapter 8 is only 2 sections as well. So very soon we'll be looking at, I saw that, very soon we'll be looking at another test. You know what I mean? So that's why I'm trying to pace this a little bit. So nobody have any questions on anything, right? Before we close out, I know we just coming out of spring break, so you may not, but I always want to make sure I throw it out there. Everybody good?
Mm-hmm.
Everybody straight?
That review on you again this semester is going to be fire. I'm just letting you know.
Well, I appreciate it.
Get up in there and type. I'm just letting you know, dude.
My daughter just found out that there was such thing as Rate My Professor, so she went looking me up the other day.
Oh. You probably got gold star. I'm not even kidding. The best team. Oh my god. I don't even know. Good.
That's what I used to sign up for your class.
Oh yeah? Okay, cool,
Yeah.
cool. That's good. All right, appreciate that. So like I said, we'll pause right here. Next class we'll look at 7-2. And we'll go from there, y'all. So I'll go ahead and let you guys go. See you on Thursday. Be safe and take care.
Awesome. Thank you so much for your time. I'll see y'all on Thursday.
All right, sounds
Thank
good.
you. See y'all later.
Yeah,
Bye, guys.
Thanks.